Hello friends, this is Praveen and today we are going to learn about the chapter motion, which is the first chapter of the class 9 physics textbook. So, what is that motion? Have you ever heard this term? So, let's take the technical definition. So, if there is a body and it is after some time when you are looking at it, after some time it is not there, but you have to turn your head to see it object. So, and after some more time you have to again turn your head to see the body and continuously doing that, then we can say that this body is in the motion. So the body was in first at this time and then it moved to here and then it is moving in the this direction. So this is defined as the motion. So the motion is the rate of change of the motion is said to be the change in the position with respect to time. So what is opposite of a motion? If body is not moving, we is said to be in a rest. So what is a rest? In which for same, let's take this block and the body after some time I see it again, but it has not changed its position. So means I do not have to turn my head. So this body is said to be in a rest. So let me ask you one question. So if you say that a person is directly coming to you, if you are sitting here and a person is directly coming to the perpendicular to you, now you have to not rotate your head in any of the direction to see that body or the person. So is this person now not really moving? Well, it is said to be moving because now if it is coming closer to you, he would get bigger and bigger. So here, if it is here, and if it then it will become and get bigger to you if you are seeing it in this perspective. So your brain will tell it is not the person that growing that much fast. So that means heat is coming towards you. And if there is a body here and if it is getting away from you, it would get smaller and smaller. Without if you are seeing here, it would get smaller and smaller. But in this direction, if it would coming to you, it would get bigger and bigger. So this is said to be in the both cases. This is said to be in motion. So if it is growing in size or it is coming towards you or leaving towards you, or if you have to turn your head to see this body, then it is said to be in the motion. And if it is not doing so, with how much long time you take, it is said to be in the rest. So we will see these both terms in depth in this video, but after the concept of the point mass or the point object. So what is a point object? Let's understand this with an example. Let's take if we have a train. So it is a long train of about, let's take the length of the train as 100 meters and it is moving with a speed of 10 meter per second and it comes from a platform. It sees a platform of 150 meters. So can you tell me the time taken by the train to cover the platform completely? So if you want to give this a try, please pause the video and give it a shot. So let's move to the solution. So when a body is coming from here, it have to complete, let's take this marker as a train. Now as soon as the train touches the platform on the starting, the timer starts, and when the train head touches the end of the platform, it has not completely covered the platform because this part of the platform, that is the train, is also left. So now what will happen until the train's last wagon do not cover the last platform, the total distance, we cannot get the correct timer, and here the timer would stop. So how much the train have to cover the distance? This platform plus its own length. So this would be 150 plus 100 meters. So the total distance which our train has to travel is 250 meters. And from the previous classes we know that d is equals to s into t, that is the distance is equals to speed multiplied by the time. So we have given the speed that is 10 meter per second, so divided by 10 meter per second, which is gives you the time of 25 seconds. So it takes the time of 25 seconds to cover this train. But now let's take the same train, but now this was the initial platform and this was the train of 100 meters, 150 meters, and the train is moving with the speed of 10 meters. This was the case, but now it is not starting from here. The train, let's this point be A. So now the train is coming from another far away point, that is point B. So point B, what is the distance between the point A and the point B? It is 1000 kilometers. So it is 1000 kilometers. So now can you tell me the time to cover the distance between point A to cross this platform? So pause this video and give it a shot. So let's see its solution. So first, we have to not take the train as it as here. We have to take this train as here. So now this train is 100 meters and it is traveling with 10 meters per second. And now the distance is 1000 kilometers. So you would take the distance as 10 and the speed is 10 meter per second. So converts it into the meter, that is 1000 followed by 3 zeros divided by 10, that is it would take 5 lakh seconds to cover this. But in this scenario we will see that we have not included the 25 seconds which in the earlier cases we have done in this example. When the train was here, I have not included that the time to cross this platform also. Why now the time taken the train to cross such a large distance is not comparable with this, or it is very less compared to this. So in the physics, if we have, when the distance of the distance traveled by the body is very great, is much more greater than the length of the body, then we take the body or consider it as a point mass. So it does not have any length. But actually it has, if you will take a technical, it would be 1025 seconds. But this is so minute compared to 1 lakh. So what is the comparison between 1 lakh and the 25 seconds? So it is very less. So we directly take this as the, this is only the distance and this is the speed. So we take here, we have taken the length of the train as a point mass. Before this, we have learned about the rest in motion. So let me ask you one more simple question. So now this, what you are in a train and you one more passenger or your friend is sitting with you in the train, and you are seeing a farmer that is cultivating his land outside the train. So what you will see this, what would he say? That your friend is in motion, but according to you he would be in the rest. So what then who would be the correct this time? You would say that the farmer would be correct because he is standing on the land which is not moving. So let's take the earth. Earth itself is moving around the sun, and the sun is also going through the Milky Way galaxy, but none of them it is in the center. So we cannot conclude that who is in the center or who is in the rest. So these both rest and motion are absolute terms. It means in which frame of reference you are talking about. So frame of reference. So in which whose frame of reference you are talking about. Let's take this body which is moving this, and here it is you and this is your friend, and there is one more person sitting. He is saying that he is moving, but the distance is not changing between you and your friend. So you would say it is in the rest and he would say in the motion. But you both are correct in this way because according to him, everything of his surrounding he considered to be the rest, and you are moving in this direction, so according to him you and your friend would be in the motion. But here are you, according to you take your surroundings as in the rest, and so it is, this position is not changing, is there a position with respect to its surrounding, it is said to be in the motion. So it is said to be in the rest with your point of view, and by the motion in the farmer's point of view, or the another person who is outside the train in your perspective, in his perspective. So these were the frame of reference. Let's take two bodies. That is, let's take two cars in which a passenger driver A and driver B are sitting, and they are moving with the same speed. Same speed, that is, it is moving with 80 km per hour, and it is also moving with 80 km per hour. So who is in motion now with respect to whom? Pause this video and give it a shot. So let's move to solution. So now these bodies are moving with in the equal speed. So now the surrounding of the A would be equal, same as the surrounding of B. So according to whom, the car B or the person B is in the rest, but according to the person B also, the A would be in the rest. So the frame of the reference are both relative terms. This depends on the person who is talking about it. Now let's move to the motion in dimensions. So what do you mean by dimensions? Dimensions we mean by the length, breadth and height. There are four types of dimension which is we have learned about, that is 0D, 1D, 2D and 3D. In 1D, none of these scenarios are present. That is, example is the point. But in length, that is 1D, only length is present, so it will be form a straight line. In 2D, it forms length as the breadth, so it forms a plane. And in 3D, it forms a solid figure because all of them is present in this. So motion means movement in the three of these dimensions. So can you tell me if there is any movement possible in 0D? Because now an object cannot move in not in any direction. So in this 0D, the motion would be not possible. So in the 0D, a body would be in the rest. But let's take example of 1D. Now if we keep the body at this point, now it would move either in this direction or either in this direction. So this type of motion in which a body moves in a straight line is known as a 1D motion. In the 2D, when the object body, if you are placing it here, it could move in any of the direction but not in the upwards direction. So it would be in the 2D, there is motion in 2D. So this is known as motion in 2D or 2D motion. And if a body could move along with the length, breadth and the height, it is known to be the 3D motion. So in the 0D, no motion would be possible. Examples of the 1D motion could be a body moving in a straight line, or a train moving in a straight line, or a ball. If you will take from a height a building and you throw a ball, it moves in a straight line. You could either throw it up or throw it down. If it is in a straight line, it is said to be a 1D motion. And instead, if you throw in this direction and the direction changes because the gravity is pulling, so it forms a curve. Now it is in the 2D motion. Examples would be insect crawling on the floor, etc. And in the motion in 3D, you can take a particle moving in a random direction or a fighter plane flying in the sky. So these are the different types of motion. That is 1D, 2D, 3D. So now let's move to the types of motion. So what are the different types of motion other than the motion in dimensions? So what are the different types of motion? A body could move in a straight line. Straight line, or it has its head locked on a point. That means if you are taking this as a point and you are spinning it, and its head is locked at the center, so it would always point towards the center. This could be another type of motion. And another type of motion you can take is a body is curving, but its head is not locked, so it would move like that way. So this, and another type of motion is if it is repeating itself after an equal interval of time. So let's take it example as a pendulum. So what are the three types of the motion? Let's name this. So the line motion and the curve motion are both classified as the linear motion. And the linear motion is in which a body is not necessary to change its position of the body. So for a line motion, it is known as a rectilinear motion, in which a body always travels in a straight line without changing its direction. And in curvilinear motion, a body would not be locked. If it is moving, the position of the body would not change, or the orientation of the body would be remain same. So it would be like this. So this type of motion is known as a curvilinear motion. And if its body's orientation is locked with a point and it is getting spin with this type of motion is known as a rotatory motion. Example would be fan, turning machine, etc. And what is a in which it repeats in equal interval of time, it is known as a oscillation or a oscillatory motion. So in which a body repeats itself in an equal interval of time. Example would be a pendulum, a clock, hands of the clock, etc. So these are the different types of the motions. Now what is the scalar and vector quantity? So if you have a friend and you have to go to his house, he says move 10 meters, but move 10 meters, it doesn't mean in which direction to move. So it would form infinite cases of directions in which you can take the 10 meters. But then he says you have to move 10 meters in each direction. So if it is there, so he have moved in each direction to reach my house. So this is the examples of vectors and a scalar quantity, in which if a term is introduced, or it can be enough to introduce with only its magnitude, it is referred to as a scalar quantity. So examples of the scalar quantity would be of distance, because let's take an auto driver, he would travel all over the place, but it doesn't tell what is the distance between your starting point and the final point. So this type of motion is known as a scalar quantities. Example would be speed, etc. And what is a vector? In a vector quantity, it have to be specified with the other terms such as the direction. Examples of it would be force, then we have is the displacement, velocity, acceleration, etc. So the scalar quantities which could be added by arithmetic operations such as plus, minus, multiplication and division. But vector quantities are specified by the vector algebra. They can be only calculated with help of an vector algebra. So these were the scalar and vector quantity. Now let's move to the distance and displacement. So you have come to a place to visit in India, and here is an airport. Now you have to travel whole the city. So you carried up an auto who would take this path. Now you started going in this pattern and returns to the original place. So from the previous grades we know that the distance covered by a body is known as the distance. So this is distance traveled. But now I have to tell what is the distance between, what is the shortest path I have to reach the starting point and the ending point. This is termed to referred as the displacement. So this is known as a displacement. So let's see the difference between distance and displacement. So first, the distance is always positive and it always increases, because if you would take the auto driver and come to the same point, it would not charge what is the distance between the starting and the ending point. It would charge what the distance you have covered, because it is his property in calculate. Otherwise, if you are going and taking a zero, and the displacement would be zero, and so there would be no cost for him, so he would be in loss. So the taxi drivers carry a distance, but in displacement, the displacement can be changed. It could be either in negative or in positive. It may increase or decrease depending upon the situation. So in the displacement, let's take, you go a body here and then returns again and return comes here. Now what is, we have seen that it is a vector quantity, so we have to take any one direction as a positive. Why do I say that the displacement could be negative? Because if you are taking this direction as negative, now the displacement from point A to point B would be this distance, which would be positive. But if you are traveling the same distance in this direction, it would be not equals to A and B. Let's take a distance. So now AB would not be equals to AC, because now it is in the opposite direction and this terms as the negative direction. The opposite direction, here the plus is not referred to as the distance, it is referred to as the direction we are taking. If we are taking this direction as positive, and this direction will be like as a negative. If you are taking the upper direction as a positive, so this direction would be negative. And if you are consider this direction to be positive, so that direction would become the negative directions. So these are the displacements. Now let's solve few questions based upon the what we have learned today. So now this is a point A, and a body goes from point A to point B, which is 5 meters, and then it from point A to point B it moves to point C, and which is 6 meters, and after that it comes to the point B again, and then to the A again, and then it goes to the point D, which is 4 meters away from them. So now what we have to find out? We have to find out what is the displacement and the distance in the each distance it has traveled, or the each interval. So first we have to find from the A to B what is the distance and what is the displacement. So let's make, this is point AB. Now from it we have to go to A, B and C. We have to find out this, and then we have to A, B and A, B, C, and then it's again coming to B. So this we have to also find out what is the distance and displacement. Then it is moving it A, then it is coming to B, and then it's going to C, and then again to B, and then it is coming to A. So we have to find out the distance and the displacement of these two. And third, we have to find out the distance of A, B, C, D, that is B, A, D. So what is the total displacement of this? So give it a shot. If you want to give it a shot, pause the video. So let's move to its solution. So what would be the distance and the displacement from point A to B? So it has covered the 5 meters. It has covered the distance of 5 meters. After 5 meters, the displacement is only this much, so it would be also 5 meters. From point A to B to C, now the distance is 5 plus 6, which is 11 meters, and the shortest distance between this and this is also 11, so the displacement is 11. But now what would happen? The body is going from is coming to back to the original position. So now what would be the distance of ABC? That is ABCB, which would be the 17 meters. But the shortest distance between A and B is now 5 meters. So it would again come to as a 5 meters. Now, if it is body is coming to the starting position, we know that the displacement would be a 0, because there will be no sign. So now it would be the 0 meters. And what would be the distance traveled? It would be going from 5 to 6, and then traveling the 6 distance back, and then 5 distance back. So the total distance traveled would be the 5 plus 6, that is 11. 11 times 2, that is 22 meters. And now what is the distance that it has traveled in total from point D? It would be 26 meters. But now the displacement between A and D, which would be the only the 4 meters. Is the 4 meter correct? Because we are taking from the reference A this direction as positive, but in this direction now it would be negative, so it would be minus 4 meters. So this was my part first of the video of the motions, and we will continue the chapter in the next video. Until then, stay tuned, and at the last, thanks for watching.